It's funny. We almost never think about the air we breathe, but that invisible stuff all around us, it's literally the most important thing keeping our planet alive. It's like this perfect invisible blanket wrapped around the Earth. So, let's pull back the covers a bit, shall we? Let's see what's really going on. All right, so here's the game plan. First, we're going to look at what this blanket is actually made of. Then, we'll see how the sun warms it up. After that, we'll dive into its surprisingly complex layers, figure out how it keeps our planet just right, and then we'll get into what happens when that whole system gets thrown out of whack. Okay, first things first. To really get a grip on our climate, we have to start with a super basic question. What is this invisible shield actually made of? The official definition is pretty straightforward. The atmosphere? It's just a bunch of gas wrapped around our planet, and the only thing holding it here is gravity. I mean, without gravity, poof, all this air would just drift off into space.
So if you look at what's actually in the air, it's kind of surprising. Almost all of it, like 78%, is nitrogen. Then you've got the oxygen we need to live, that's about 21%. But the really interesting part, the key to this whole story, is hiding in that tiny little 1% slice labeled other gases.
Yeah, because tucked away in that 1%, you find gases like carbon dioxide, CO2. And even though there's hardly any of it, these gases are a huge deal. Why? Because they're really, really good at trapping heat. That gives them this outsized impact on our planet's temperature. Okay, so this blanket of air, it doesn't make its own heat. It gets all its warmth from one place and one place only, the sun. So let's talk about how that works. Now, there's a fancy word for this. It's called insolation. Sounds a bit technical, right? But all it really means is incoming solar radiation, the energy we get from the sun. That's it. It's the engine for our whole climate. And here's a great way to picture how this works. Think about the sun's rays at the equator. They're coming straight down, right? It's like a spotlight, focusing all that energy on a really small spot. Super concentrated, super hot. But now, what about at the poles? The rays are hitting the Earth at a sharp angle, so that same amount of energy gets spread out over a much bigger area. It's like taking that spotlight and turning it into a wide floodlight. The light is way less intense, right? And that means less heat. This is literally why the equator is hot and the poles are cold. Simple as that. So, this blanket, it's not just one big blob of air. Not at all. It's actually got layers, like a cake, and each layer is totally different. So if we start from the ground and go up, you can see the different layers right here. We're down here in the troposphere. Right above us is the stratosphere. That's where the ozone layer lives. Then you have the mesosphere, and then it just kind of fades out into space. Now, for our purposes, the only layer we really need to focus on is the one we're in right now, the troposphere. This is our home. It's where we live, where planes fly, and most importantly, it's where all our weather happens. I mean, think about it. Everything you think of as weather, clouds, rain, hurricanes, you name it, it's all cooked up right here in the troposphere. This is also where you find the jet streams, those super fast rivers of air way up high that can push a plane along. Okay, so we've got our layered blanket and it's getting warmed up by the sun. But how does it hold on to that warmth? Why doesn't it all just escape back into space at night? Well, the answer is a totally natural process called the greenhouse effect. And this is super important. The greenhouse effect gets a bad rap, but it's not a bad thing on its own. It's completely natural. Remember those tiny 1% gases we talked about? Well, things like CO2, they act just like the glass on a greenhouse. They let the sunlight in, but they don't let all the heat back out. And honestly, without this effect, Earth would just be a frozen ball of ice. It's not an exaggeration. As the source material puts it, the only reason life is even possible here is because this blanket holds in just enough heat to make things, livable. But here's where the story takes a turn. What happens if you have a perfectly good blanket and you just start piling on more and more blankets? You'd get way too hot, right? Well, that's exactly what we're doing. We're making our planet's blanket too thick. And it all really kicked off during the Industrial Revolution. That's when we started burning fossil fuels, coal, oil, gas on a massive scale. And all that burning started pumping enormous amounts of extra CO2 into the air. And wow, this graph really tells the story, doesn't it? Look at it. For hundreds and hundreds of years, CO2 levels were pretty much flat, stable. Then, right around 1850, it just skyrockets.
We shot up from around 300 parts per million to over 410 today. In the grand scheme of things, that's like a blink of an eye.
And just to give you some perspective on that, scientists have looked at ice cores that go way, way back. And they've found that CO2 levels today are higher than they've been in at least, get this, 800,000 years. That is just staggering. We are way outside the natural rhythm of the planet.
So, what's the result of this sticker blanket? Well, pretty simple. It traps more heat. And that extra heat kicks off this huge domino effect all over the globe. You can see from this diagram, it's not just one thing. It's a whole web of connected problems. Okay, so let's walk through it. That extra heat, it melts ice caps and glaciers. All that water has to go somewhere, so it flows into the oceans, making sea levels rise. And more energy in the system, that means more fuel for wilder weather, bigger storms, crazy heat waves, and longer droughts. And it's not just the air. The oceans are soaking up heat too, and that's wreaking havoc on everything from coral reefs to entire food chains.
So we started this whole thing by talking about our atmosphere as this perfect, life-giving blanket. It created the ideal conditions for life to flourish. But now, by making that blanket thicker, we're changing those conditions, and we're doing it at an incredible speed. So it really leaves you with one big question, right? How are the things we do now going to define the future of this amazing, fragile system that keeps us all alive?